What I've done is I've copied that diagram that I created in GeoGebra and I put it into the smartboard so that we have a workable document that we can write on and start analyzing our distance formula. In order to use a distance formula, you have to know the coordinates of the points A, B, C, and D. Well, we can describe the coordinates of points A, B, C, and D using our trig ratios. So that's the first thing we're going to do is we're going to start putting on order pairs for points A, B, C, and D. I'm going to start with point D, and point D is the easiest one to find because point D has coordinates that are whatever the length of the radius is. So because these ships took off at the same time, the same distance, whatever distance they travel, it's going to be the same distance or the radius. And that radius is going to be the same no matter where we are. So this has, on this point D, I can simply call this the order pair r, comma, 0. Then when I go to point C, what I want to do is be able to describe the coordinate of point C using sine and cosine. Well, our angle is alpha minus beta. Now that's what that angle was. We calculated from the difference of those two angles over here, which is about 50 degrees. So we're going to use the cosine of alpha minus beta times r would be the x-coordinate of our order pair C, and r times the sine of the angle, which is alpha minus beta, would be the y-coordinate of point C. So I just put in the coordinates for point C, work around them, and you get to point B. Now point B, it had a different angle. Our angle for this one was beta, which is 110 degrees, or all the way around here. We can use our reference angle, but we also have the coordinates that can be described as r cosine of beta, comma, r sine of beta. So those are our coordinates for point B. Our coordinates for point A are going to be written as, or in terms of its angle, which was alpha. So this is going to be r cosine of alpha, comma, r sine of alpha. Okay, now I'm going to organize those and put them down here so I have a nice, neat group of numbers to work with. So A had coordinates of r cosine of alpha, comma, r sine of alpha. B had coordinates of, and that should have been r cosine of beta, r sine of beta. Point C had coordinates of r cosine of alpha minus beta, comma, r sine of alpha minus beta. And point D had coordinates of r, comma, 0. As I kind of introduced in the video, what we're going to do is we're going to calculate the distance between point E and F, or B, A, and the CD. So in order to find the distance, we have to bring up our distance formula. The distance formula is given by x sub 2 minus x sub 1, the x-coordinates, the difference of those squared, plus the difference in the y-coordinates squared. And we want to make sure that that's going to equal the distance of another segment, which is going to be calculated by the same formula, the distance formula. And really the distances that we're saying have to be equal in length are our segments from A to B. I'm just going to highlight those. From here to here, that segment had to be equal length to CD, again because they have the same central angles. If the angles are the same, then the intercepted arcs are the same, and the chords that cut them off are the same length. So here's our proposition that we can figure out the distances between those 2 points by using our distance formula. So here's where you got to be really careful and hopefully not make any silly mistakes. I want to find the length from A to B, and I know it's got to be equal to the length from C to D because of the analogy I just used. So in order to find the length of segments AB, we have to take the x values and subtract them. So it's going to be the square root of, and the x values are r cosine of alpha minus r cosine of beta. We want to square those, plus. Now we want to take the y values and subtract those, so it is r sine of alpha minus r sine of beta, and square those. And that's got to equal, now CD is the square root of, the difference in the x-coordinates are r cosine of alpha minus beta minus r, that has to be squared, plus, and then on the y-coordinates, it's r sine of alpha minus beta minus 0 squared. Extend that line, and this is the distance formula that we're working with. So the first thing we're going to do is we're going to square both sides, because I do not want to work with those radicals, and if I want to undo square rooting, we undo it with squaring. So I'm squaring both sides. So when I square both sides, it basically eliminates the radicals. So we still have r cosine of alpha minus r cosine of beta squared plus, now we have r sine of alpha minus r sine of beta squared equals, on the other side we get rid of the radical and we're left with r times the cosine of alpha minus beta minus r squared, then plus, and this one we're going to simplify. Subtracting 0 doesn't do anything, so it's just r sine of alpha minus beta squared. Okay, now we have the fun of expanding these binomials. So when you square a binomial, you get a trinomial. So I'm going to square this. So when we square the first term, it's r squared cosine squared of alpha. You got to double your outside inside, so it's going to be minus 2 of these r squareds cosine of alpha cosine of beta, then plus r squared cosine squared of beta. So this has been, we're taking the place of this, all we've done is we've squared it. So I'm going to change colors here to make sure I keep track of where all these numbers came from. So now I'm going to square the second binomial. So that is r squared sine squared of alpha minus 2 sine of alpha, backtrack just a bit, minus 2 r squared sine of alpha sine of beta. I'm trying to be careful not making any mistakes, but hope I don't. Then we've got to square the second term is plus r squared sine squared of beta. Now that's just squaring this binomial. So I got two trinomials from squaring those two binomials. You can see the equation is getting quite long. So I'm going to have to come over here to wrap around. Now I'm going to be squaring this binomial. So when I square that, it's going to be r squared cosine squared of alpha minus beta. Then we got to do the outside inside, so minus 2 r squared cosine of alpha minus beta. Then it's going to be plus r squared. And this is the squaring of this binomial. So square the first term, double the outside inside, 2r squared cosine of alpha minus beta, plus square the last term. Got it. So then the last thing I have to do is I have to take this one and square it. Since it's not a binomial, that's a whole lot easier to do, so it's just going to be plus r squared sine squared of alpha minus beta. Okay. Now we could do some factoring, but I'm going to just use a division property of equality. What I want you to notice is that in every single one of these terms, so I'm going to try to highlight each and every one of those, every single one of them has an r squared. So I'm going to circle it. There's an r squared in this one. There's an r squared in this term. So as long as it's in every term, what I can do is, what I'm going to do at least, is I'm going to divide this entire equation by r squared. Okay, so when I divide the entire equation by r squared, those r squareds are going to cancel. So this is going to be r squared divided by r squared is 1. That'll become a 1. That'll become a 1. 1, 1, 1, 1, 1. Here's where we got to be really careful. This becomes a plus 1. Got to remember that one. Then cancel out the r squared, which is a 1. So we've got a little bit of a condensed equation now that says we have cosine squared of alpha minus 2 cosine of alpha cosine of beta plus the cosine squared of beta, then plus a sine squared of alpha minus a 2 sine of alpha sine of beta plus sine squared of beta. Now I just hit the equal sign, so come down here and change colors again, equals. Now this is our stuff in black. We've got a cosine squared of alpha minus beta minus 2 cosine of alpha minus beta, then plus our 1 that was here, then plus a sine squared of alpha minus beta. Okay, so I'm going to pause and I'm going to double check my work so I don't have any errors before I continue on any further. So give me a moment to check. Okay, so far so good. I'm 10 minutes into this and I didn't want to have to go back and say, whoa, silly mistake. Let's go back and redo some things. So next thing, what we're going to do is we're going to identify some Pythagorean identities. Without having to rewrite and rearrange everything, a cosine squared of alpha plus a sine squared of alpha, if we put those two together, they become a 1. So that's a 1. We also have another one here I think we can do. We have a cosine squared of beta and another sine squared of beta. That's a Pythagorean identity, so that is a plus 1. And then we have these two guys here, a 2 cosine of alpha, cosine of beta, and a 2 sine of alpha, sine of beta, and they're both minus, so I'm going to factor out a 2, a negative 2, and it's going to be cosine of alpha, cosine of beta, then plus, since I factored out the negative 2, sine of alpha, sine of beta, parentheses. So I simplified the left side, and now I might be able to get it all in one equation, equals. And over here, we have a cosine squared of alpha minus beta, and a sine squared of alpha minus beta. This is a Pythagorean identity. It is equal to 1. So those two cancel to a 1, or simplify to a 1. Then minus our 2 cosine of alpha minus beta. So let's see what kind of things that we can simplify. If we subtracted 1 from both sides, that 1 and that 1 could be eliminated. And then we would have the resulting equation of 1 minus 2 times the cosine of alpha, cosine of beta, plus sine of alpha, sine of beta, equals a negative 2 cosine of alpha minus beta. So I'm going to pause again here quick. Okay, well I'm glad I did that pause in there because I was able to catch something that I overlooked. Back here in this equation here, there's another plus 1, so I got to get that in here, and that came from this bottom part down here. I was missing a plus 1, and then what I can do is I can get rid of another plus 1 and plus 1. So this plus 1 and this plus 1 will reduce, which will take out this 1 out here. Okay, so looking at that, looks like we could divide both sides by a negative 2. So if we divide both sides by a negative 2, showing that, then we have our negative 2's reducing, so we have the cosine of alpha times the cosine of beta plus the sine of alpha, sine of beta equals the cosine of alpha minus beta. And all of this was to show you that there is a way to derive this formula. It was through the distance formula to find the difference of the angles of, in our scenario, 2 ships sailing away at the same speed, same time. So all this effort was an attempt to show you the derivation of the cosine of a difference formula. So quite involved as far as squaring and square rooting, but once you look at the whole thing, it's everything that's manageable, things that we've covered, how to identify ordered pairs in the coordinate plane, how to use a distance formula, how to square binomials, how to collect some like terms, apply some Pythagorean identities, and a few properties of equality. So, like I said, this is my best attempt of showing you the derivation of the difference of, or the cosine of a difference. So, I will stop this video and now we'll go into the derivation of the remaining trig identities for sum and differences.